Okay friends, welcome back. Again we are going to discuss about mixers. Mixers. What is a block diagram of mixers? In mixers RF amplifier will be present and mixer will be present, and then IF amplifier filter is present, and then demodulator is present, and again baseband amplifier is present, and then it is connected to output. Tuning control. Tuning control local oscillator. In RF architecture, mixer circuits translates RF signal into low frequency so that the immediate IF frequency uses fixed band pass filters. Tuning is now accomplished by varying the frequency of the local oscillator rather than by varying the center frequency of a multi-pole band pass filter. And then mixers block diagram. Thus, instead of adjusting several LC networks to tune a desired signal, one simply varies a single LC combination to change the frequency of a local oscillator. The intermediate frequency stages can then use fixed band pass filters. Selectivity is therefore determined by these fixed frequency IF filters, which are much easier to realize than variable frequency filters. The overall gain of the system is distributed over a number of different frequency bands. So, what are mixer fundamentals? Since linear time invariant systems cannot produce outputs with spectral components, mixers must be either nonlinear or time varying elements in order to provide frequency translation. All mixers presently in use is a multiplication of two signals in the time domain. The fundamental usefulness of the multiplication may be understood from the following identity. Multiplication: A cos omega 1 t input from receiver, that is given to B cos omega t, y is equal to AB by 2. So A cos omega 1 t into B cos omega 2 t is equal to AB by 2 of cos omega 1 minus omega 2 of t plus cos of omega 1 plus omega 2 into t. Multiplication thus results in output signals at the sum and difference frequencies of the input. Signals whose amplitudes are proportional to the product of the RF and local oscillator amplitudes. Hence, if the local oscillator amplitude is constant, any amplitude modulation in the RF signal is transferred to IF signal amplitudes. And next, mixers. These mixers are divided into four types, that are linear mixers, multiplier based mixers, subsampling mixers, and double ring mixers. Okay. Linear mixers are divided into two types, square law mixers and single bipolar transistor mixers. And again, multiplier based mixers are divided into that are four types that are single balanced mixers, active double balanced mixers, potentiometric mixers, passive double balanced mixers. And then double ring mixers are divided into three types: single double mixer, two double mixers, and double balanced double mixers. Multiplier based mixers. Since two-port mixers have only one input port, the RF and local oscillator signals are generally not well isolated from each other. This lack of isolation can cause the problems such as overloading of IF amplifiers as well as radiation of the local signal back out through the antenna. Mixers based directly on multiplication generally exhibit superior performance because they ideally generate only the desired intermodulation product. We need high degree of isolation among all three signals, that is RF, LO and IF. Finally, CMOS technology provides excellent switches and one can implement outstanding multipliers with switches. Single balanced mixer figure is like this. Single balanced mixer figure. So VLO and IDC current plus IRF cos omega RFT. Single balanced mixer, one extremely common family of multipliers, first converts the incoming RF voltage into a current and then performs a multiplication in the current domain. In this mixer, VLO is chosen large enough so that the transistors alternately switch all of the tail current from one side to the other at the local oscillator frequency. The tail current is therefore effectively multiplied by a square wave whose frequency is that of the local oscillator. I out of t is equal to SGN of cos omega L0 t into I bias plus IRF cos omega RF into t. Single balanced mixers, because a square wave consists of odd harmonics of the fundamental, multiplication of the tail current by the square wave results in an output spectrum that appears as shown. These are the representative output spectrum of single balanced mixer. The output thus consists of sum and difference components, each the result of an odd harmonic of the local oscillator signal mixing with the RF signal. In addition, odd harmonics of the local oscillator appear directly in the output as a consequence of the DC bias current multiplying with the local oscillator signal. Because of the presence of the local oscillator in the output spectrum, this type of mixer is known as a single balanced mixer. Although the current source of figure includes a component that is perfectly proportional to the RF input signal, VI converts of all real mixers are imperfect. Because of the presence of the LO in the output spectrum, this type of mixers is known as single balanced mixers. Although the current source of figure includes a component that is perfectly proportional to the RF input signal, VI converter, so all real mixers are imperfect. Hence, an important design challenge is to maximize the linearity of the RF transconductance. Linearity is most commonly enhanced through some type of source degeneration in both common gate and common source transco. So, common source, common gate transconductors for mixers are shown below. Are shown below. RF transconductors for mixers. The common source and the common gate diagrams are shown in the below. Are shown in the figure. Though that transco linearity the most commonly enhanced through some type of source regeneration in both common gate and common source transco. Okay. Next. The common gate circuit uses the source resistance Rs to linearize the transfer characteristics. This linearization is most effective if the admittance looking into the source terminal of the transistor is much larger than the conductance of RS. So, in that case, the transconductance of the stage approaches 1 by RS. Inductive degeneration is usually preferred over resistive degeneration for several reasons. And then a more complete single balanced mixer that incorporates a linearized transconductance is shown in figure. The value of B bias establishes the bias current of the cell while RB is chosen large enough not to load down the gate circuit and also to reduce its noise contribution. The RF signal is applied to the gate through a DC blocking capacitor. Next, the amplitude of the fundamental component of a square wave is 4 by pi times the amplitude of a square wave. We may write Gc is equal to 2 by pi into Gm, where Gm is the transconductance of the V2I converter and Gc is itself a transconductance. The coefficient is 2 by 5 rather than 4 by 5 because the IF signal is divided evenly between sum and difference components. Next, active double balanced mixture. To prevent the local oscillator products from getting to the output in the first place, two single balanced circuits may be combined to produce a double balanced mixer. Okay. So here this is the figure for active double balanced mixer. We assume once again that the local oscillator drive is large enough to make the differential pairs act like current steering switches. Current steering switches. Note that the single balanced mixers. Note that the single balanced. Therefore, the local oscillator terms sum to 0 in the output and does not appear at output, whereas the converted RF signal is doubled in the output. This mixer thus provides a high degree of LO-IF isolation, easing filtering requirements at the output. Active double balanced mixer. The basic linearizing techniques used in the single balanced mixer may be adopted to the double balanced case as shown in the figure. In low voltage applications, the DC current source can be replaced by a parallel LC tank to create a zero headroom AC current source. The resonant frequency of the tank should be chosen to provide rejection of whatever common mode component is most objectionable. If several such components exist, one may use series combinations of parallel LC tank circuits. With such a choice, a complete double balanced mixer appears as shown in the figure. The expression for the conversion transconductance is the same as for the single balanced case. Next, potentiometric mixers. What are these potentiometric mixers? Gilbert type mixers first convert an incoming RF voltage into a current through a transconductor whose linearity and noise figure set a film bound on the overall mixer linearity and noise figure. An alternative to using voltage controlled current source in VI converters is to use voltage controlled resistance. For example, consider varying the resistance of a triode region MOSFET in a manner inversely proportional to the incoming RF signal. If the voltage between drain and source is maintained at a fixed value, the current flowing through the device will be a faithful replica of the RF voltage. Here will be the faithful replica of the RF voltage. And if VDS varies with the LO, then the current will be proportional to the product of the local oscillator and RF signals.